Hello, it's Luntan. We'll get started. Today is week 13. We are on abstract syntax tree. This is the part two for the syntax analysis. Part one, we talk about overall idea of the syntax tree parsing. And this one actually talking about the detailed mechanism of the whole parser. So the topic in this week would be the attribute grammar, evaluation of the attribute, action routine, tree grammar, syntax tree declaration. These are the steps that people try to build a parsing tree, and then later is the parser generator, and parser combinators. Okay. So basically, again, here we talk about starting to from design of the parser and the generation of the abstract syntax tree, and then declaration of the syntax tree, and then creating the semantic graph. So attribute grammar actually is from your grammar, your context-free grammar. We start to do declaration, making sure that the action items in the grammar can be added. So primarily for the creation of the target code. So the regular context-free grammar like this, you have a set of the context-free grammar. So expression equals expression plus term. Expression equals expression minus term, something like that. Okay, F is a vector. Okay, this is actually a calculator grammar. And then you actually start to decorate it. So you actually start to have the attribute grammar like this. So your left-hand side, E1 evaluate. E1's value would be the sum of the right size value. So this is basically working on the semantic idea of the grammar. So this is for the declaration of your syntax tree to semantic grammar. Okay, graph. So something like that, you actually have different grammar, okay, and we do talk about the generation of attribute grammar, okay, whatever. So I just roughly go through this idea, making sure that you know what these different chapter are. The detailed explanation, you need to watch the video and then let me know if you have any question. So attribute grammar is a special form of context-free grammar where additional information called attributes. Attributes you can think about functions, extra function to evaluate your semantic values or action items. So attribute grammar is a medium to prove semantics, to provide semantics to the context-free grammar. So you have a grammar. Grammar, you actually put some what your grammar rule should be, but there is no evaluation part. So attribute grammar is to add those value-related topic up down to your grammar. So when you do the reasoning, you actually also will evaluate your data to make sure that it makes sense. And then you may find type difference, type of mismatch. You may find division by zero, those kind of error when you do compilation. So here you have the grammar. And so we call it a semantic attributes. Okay, so you have a set of predicate and attribute values. And then there are two type of the attribute, synthesized attribute, and the other one called inherited attribute. The synthesized attribute means that your value is determined by your children's. Okay, value of the current node is in function of the children's. So this happens when you have a, say you have a expression equal to term plus term. So these two terms value would actually give the value of the expression. So this is a synthesized attribute. Your value depending on your children's. And another one is inherited attribute. That means your attribute inherited from your parents and siblings. So parents and siblings means like you have a double as HB equals D plus I. Okay, so this one you actually have the double integer. So the attribute of the data type on the I will become a double because this type would determined by the parents and its siblings. So basically, this is a inherited attribute. The attribute coming from your parent or your sibling, and the assignment statement is one of the example. So you have a synthesized attribute and inherited attribute, and when you do evaluation tree, you will actually determine decorate your attribute. So you may do bottom up to sum up your synthesized attribute. You may do top down to actually provide the data type. Okay, so it's up to which attribute we are talking about. So the attribute had two types, inherited attribute and the synthesized attribute. So reduction is bottom up. Okay, you actually do bottom up syntax directed translation as S attribute, synthesized attribute. And then there's another type called L attribute. This form of the SDT both synthesized inherited attribute with restriction of not taking the value from the right subroutines. So this is called L attribute. So S attribute is a subset of the L attribute. L attribute evaluate depth first, left to right parsing format. And then S attribute is bottom up. So there are two types of the attribute evaluation. So when you evaluate, the first one, we talk about what is the attribute. And then this is section talking about how to evaluate the attribute. So evaluating the attribute, you will go this way, go bottom up. And then L type attribute, you actually will pass your value to your right-hand side. And it evaluate, you pass the value to the right-hand side. It evaluate, pass the value to the right-hand side. So right here you have a 9 expression, and then expression 2 or tail will be 9 minus some value, 9 pass over, and then there is a constant 4. So 9 minus 4, it becomes 5. 5 pass over to the right-hand side. Right-hand side has a minus 3, it becomes 2 and 2 and 2, that actually returning a 2 to the top one, returning a 2 to the top one, returning to the top one. So eventually the whole thing 9 minus 4 minus 3, we got a 2. So this is the ST state and the value. Status means that your previous data. This is L-shaped attribute. Okay, so with that, you decorate, okay, I'm sorry, ST is for subtotal. Subtotal means the previous subtotal. Okay. It is also a state variable anyway. And then you actually have every grammar rule, you decorate them with the attribute grammar. And then you can do evaluation. Okay, so that is the basic idea of L-shaped attribute and S-attribute attribute. In addition to that, you actually, when you can also use something called attribute flow. Attribute flow means that you will generate a evaluation tree and you go down to it. It's called attribute flow. Attribute flow is your execution flow. And your production rule has such a rule over here. So basically, attribute flow is when you will generate a rule and what action you will take. Okay, it's a function call actually. So the attribute flow algorithm propagate attribute values through the parsing tree, okay, by traversing the tree according to the set and dependency. So it will tell you what action you should take and what is your next step. So this kind of attribute flow is your function call when you will call what. So a compiler would actually build a grammar and then do evaluation of the tree. And this different function flow, we call it action routines. And the action routine actually is a function that you will evaluate. So this also eventually, let's actually look at the eventually. Eventually you'll be put into a whole table to build a syntax tree. So there are quite many slices, and then here we have an example of you have a program like this, and you will analyze it to a decorated syntax tree like that. And so far, this one without decoration. And starting from here, this calculator language we got decoration examples. Okay, so this example you need to go through it step by step. So these different items, they do an analysis and start to decorate with the different type of the attribute and the inherent attribute and synthesized attribute. And then some attribute is error in, some attribute is error out. Error in means that what error you carry from the previous one. Error out means that your value that would be your error that would carry out to the next step. So basically, these are different attributes. So attributes are values that you actually collected so far, including the error, your value, and your data types, those kind of informations. And then usually these are the informations that your compiler may report. So you actually have this different kind of decorated value. And then eventually your attribute grammar being added to your calculator grammar. And here are the attributes. Okay, and the whole thing can build a content-free grammar state machine. So this whole thing is the evaluation tree of different error in, error out variables. And then you can build a recursive descent parser. So right here we have the example using the Python to do it. So showing you how to define a recursive descent parser in Python. Okay. So you should trace it. There are also sample program you can download. And then the calculator language as an example. And then the JSON grammar. Okay, another example for JSON grammar. Okay, anyway, here we do present you three different parsers and in Python format and for your reference. So this chapter basically going through the building of a parser and then also give you some example. And again, our Monday session is supposed to be a session for question and answer, but so far still no student coming in. So I'm going to finish this session early, okay? If you have question, let me know. Thank you. Bye now.